Hey, I'm Zach.
And I'm Aaron.
And we're talking about plate tectonics. The first thing that we're talking about is how thermal energy works to move the plates. And there's two ways to transfer it, conduction and convection. Convection is where the plate, it heats up and it moves up. And then it cools and then moves over. And then while it is cooling, it heats down, but then it heats up and then it just keeps on going in the same cycle.
Conduction is when the two plates touch each other and it transfers the heat. Like that. And it also can cause the transform boundaries where the heat can transfer in a transform boundary when they rub against each other, go in different directions.
Pause it.
Some of the results of a transform boundary are earthquakes.
If this earthquake happens underwater, it causes an abnormally large wave called a tsunami. This happened in the South Pacific a couple of years ago to a place called Indonesia.
It also happened in Haiti last year. An earthquake happened caused by a transform boundary in Haiti last year.
With the tsunami, the waves can be over 100 feet long and moving at higher speeds than 100 miles per hour.
Now, let's talk about the different type of boundaries.
The first type of boundary is a convergent boundary. This is where two plates collide and rise up.
A special type of convergent boundary is when they run into each other and one of the two goes under it and the other one goes above it.
This is called a subduction zone. The next one is called a divergent boundary. This is where two plates spread apart.
The next type is a transform boundary, where the two plates rub against each other, going side to side.
Happen. Different things can form at these types of boundaries.
For example, mountains.
Mountains can form at convergent boundaries where the two plates hit each other and rise in the air.
Also, at subduction zones, because the lower plate pushes the above plate up in the air for a mountain.
At a subduction zone, it can also form a trench, but mountains form at divergent boundaries. This is where like the Mid-Atlantic Ridge came from. This is because the magma rises in the air, it cools and hardens and forms a mountain or a volcano.
Next is landforming islands.
Landforming can be like Hawaii, where the magma does rise, it's the same thing as mountains. At a divergent boundary where the magma rises in the air, it cools and hardens.
Next, we're done. Before spreading has been proven with much evidence.
We can tell this because rocks, or in this point the girls, the older ones go off to the side and the new ones come in the middle.
This proves Pangea. Okay.
I messed it up.
Pangea is where all the continents were connected a while back. They spread because of seafloor spreading, but before you could literally walk from one continent to another.
Hey Zach, how's South America?
Pretty good, Aaron. How's Africa?
It's alright. I think I'll come over with you.
Oh, alright. What's up, buddy?
This is a Zachosaurus. We find many fossils here in Africa. We find Zachosaurus also here in South America. This Zachosaurus is an unamphibious animal, which means it can't swim. Saying that it can't swim means that it had to walk across the continents to get from Africa to America, which proves that Pangea was real.
The same plant and animals could be found in different continents because of Pangea.
These plants and animals moved across to either continent when Pangea was still together, and as it separated, they would reproduce on each side, having the animal and plant life abundant on each continent.
Radiometric dating is a way of telling how old everything is by how much it decayed. These pages, you can tell that they're very torn, yellow, and tattered.
But with this book, you can see that all these pages are crisp, new, and still very colorful, which represents that it is young.
This book's older.
This book is younger. Magnetic reversal proves that both sides of the Earth are going through seafloor spreading.
This is because the Earth's magnetic field reacts with the rocks, and when the rocks react with the magnetic field, they form magnetic strips, and the magnetic strips on both sides of the seafloor are the same, so the Earth is moving at the same rate on both sides. Metamorphic rock is rock that has been changed over intense heat and pressure over a long period of time. This normally happens in lava and some types of magma.
This was our presentation about plate tectonics and how the Earth's interior works.
Hey, let's go home.
Okay.